Good morning, children. Tomorrow you are going to write the chemistry test. For that, now we are going to take the revision. Okay. And you know, there are two lessons for this monthly test. That is a transition and inner transition elements, as well as the next lesson is ionic equilibrium. Okay. Now we are going to see the ionic equilibrium. Okay. Ionic equilibrium is the second volume, first lesson. And that lesson PDF form I already gave. And now you are going to take that lesson and you are going to see the question and answer for that. Okay. Shall we see? Everybody take the second volume and you wrote the question answer in your notebook. That also you should take. And now we are going to see the question and answer. Okay. Question and answer of the lesson ionic equilibrium. First question. Choose the best answers. Answers are given in your book itself. So first you can read those. Choose the best answer. We will start from the question and answers. Okay. Question 1. What are Lewis acid and bases? Give 2 examples for each. That we studied. Lewis acids are nothing but a species that accepts an electron pair, and Lewis acid is a positive ion or an electron deficient molecule. And for that the example is Fe2 plus CO2, BF3, SiF4, etc. Then Lewis bases. Lewis base is a species that donates an electron pair. Lewis base is an anion or neutral molecule with at least one lone pair of electrons. For example, ammonia, fluoride ion, CH2, double bond CH2, that is ethene, and calcium oxide, etc. Then question number 2. Discuss the Lowry and Bronsted concept of acid and bases. The answer is, according to Lowry and Bronsted concept, an acid is defined as a substance that has a tendency to donate a proton to another substance, and base is a substance that has a tendency to accept a proton from the other substance. When hydrogen chloride is dissolved in water, it donates a proton to the latter. Thus, HCl behaves as an acid and H2O behaves as a base. The proton transfer from the acid to the base can be represented as HCl plus H2O gives H3O plus Cl minus. When ammonia is dissolved, another example, when ammonia is dissolved in water, it accepts a proton from water. In this case, ammonia, that is NH3, acts as a base and H2O is an acid. The reaction is H2O plus NH3 gives NH4 plus OH minus, that is hydroxyl ion. And here HCl is a proton donor and H2O is a proton acceptor. So proton donor, and in the product H3O plus is a proton donor and Cl minus is the proton acceptor. So H3O plus donate a proton to the chloride to form HCl. The products also behaves as an acid and base. In general, Lowry and Bronsted reaction represented as acid 1 plus base 2 gives acid 2 plus base 1. The species that remains after the donation of a proton is a base, that is base 1, and is called the conjugate base of the Bronsted acid, that is acid 1. In other words, chemical species that differ only by a proton. Proton is nothing but a hydrogen. Hydrogen மட்டும் differ ஆயிருந்தா அந்த pair வந்து conjugate acid and base pair. In this example, it is given HCl and Cl minus. One is the reactant and another one will get from the product. So HCl and Cl minus, those are all differ one proton. So those are called as conjugate acid and base pair. Like the same H2O and H3O plus ion, in this also one proton is a differ from those two. So those two also called as the conjugate acid and base pair. Okay. Next one, question number 3. That is, identify the conjugate acid and base pair for the following reaction. Here 3 reactions are given. HS plus HF gives fluoride ion and H3S ion. Those answers are HS minus plus HF gives F minus and H2S. In this one, HS and H2S, they differ one hydrogen ion So that is called as conjugate acid and base. And next one is HF gives a fluoride ion, that two also differ by only one hydrogen. So that is also called as conjugate acid and base. Like the same in the second reaction, HPO4 minus and HSO3. That is PO4 3 minus is a conjugate acid and base pair. SO3 2 minus and HSO3 minus. Those are another one pair of conjugate acid and base. And the third one is ammonium ion plus carbonate ion gives ammonia plus bicarbonate ion. In this one, the ammonium ion, that is NH4 plus and NH3, those two are one conjugate acid and base pair, and carbonate ion and bicarbonate ion, they behave as a conjugate acid and base pair. Next one is question number 4. Account for the acidic nature of HClO4 in terms of Bronsted and Lowry theory. Identify its conjugate base. The answer is, first you should write the decomposition reaction, that is HClO4 gives H plus and ClO4 minus. According to the Lowry and Bronsted concept, a strong acid has a weak conjugate base and a weak acid has a strong conjugate base. So now let us consider the conjugate bases ClO4 minus, ClO3 minus, ClO2 minus and ClO minus. They formed the acids HClO4, HClO3, HClO2 and HOCl respectively. These anions are stabilized to a greater extent. It has a lesser attraction from proton and therefore will behave as weak base. Consequently, the corresponding acid will be strongest because weak conjugate base has a strong acid and strong conjugate base has a weak acid. The charge stabilization mechanisms in the order ClO minus, ClO2 minus, ClO3 minus and ClO4 minus as an ascending order. That means ClO4 minus will have the maximum stability and therefore they will have the minimum attraction. Thus, ClO4 minus will be weakest base and its conjugate base HClO4 is the strongest acid. So, the conjugate ClO4 minus is the conjugate base of the acid HClO4. Next, question number 5. When aqueous solution of ammonia is dissolved in copper sulfate solution, the solution turns deep blue in color due to the formation of the tetraamine copper 2 complex, that is H2 Cu H2O 6 times 2 plus in aqueous solution plus 4 NH3 gives Cu NH3 4 times 2 plus aqueous. Among water and ammonia, which is the strongest Lewis base, that is ammonia is the strongest Lewis base. So the answer is copper 2 sulfate solution, for example, contains the blue hexa aqua copper 2 complex ion. In the first stage of the reaction, the ammonia acts as a Bronsted-Lowry base with a small amount of ammonia solution. Hydrogen ions are pulled off 2 water molecules in the hexa aqua ion. This produces a neutral complex, one carrying no charge. If you remove 2 positively charged hydrogen ion from a 2 plus ion, then obviously there is not going to be any charge left on the ion because of the lack of charge. The neutral complex is not soluble in water and so you get a pale blue color precipitate, that is CuH2O 6 times 2 plus 2 NH3 CuH2O 4 times OH plus 2 NH4 plus ion. This precipitate is often written as a CuOH twice and it is called as copper 2 hydroxide. The reaction is reversible because ammonia is only a weak base. That precipitate dissolves if you add an excess of ammonia solution and so you will get a deep blue solution. The ammonia replaces 4 of the water molecules around the copper to give tetraamine diaqua copper 2 ions. The ammonia uses its lone pair to form coordinate covalent bond with copper. It is acting as an electron pair donor and a Lewis base. CuH2O 6 times 2 plus 4 ammonia gives CuNH3 4 times H2O2 the whole part 2 plus, that is 2 plus ion cation plus water. Next is question number 6. The concentration of hydrogen ion in water sample is found to be 2.5 into 10 power minus 6 moles. Identify the nature of the solution. This is from the pH problem, SMR problem. Concentration of OH minus ion in the water sample is found to be 2.5 into 10 moles, 10 power minus 6 moles. So pOH, the formula is minus log OH minus base 10. pOH is equal to, if you are substituting that value, minus log 10, 2.5 into 10 power minus 6. So this we can split into 2, that is minus log 10, 2.5, minus log 10 power minus 6. And log 10 for log value of 2.5 is nothing but minus 0.3979, and this one becomes minus 6. So minus of minus 6 is converted into plus 6. So the pOH value is 5.6. We know that pH and pOH is equal to 14, and if you are substituting pOH value here, pH plus 5.6 is equal to 14. Therefore, pH is equal to 14 minus 5.6. We will get 8.4. So if the pH is here, the pH is more than 7. So this shows the nature of the solution is basic. Next one is also in the form of a problem. A lab assistant prepared a solution by adding calculated quantity of HCl gas 25 degrees centigrade to get solution of hydronium ion, which is whose concentration is 4 into 10 power 5 moles. Is this solution neutral or acidic or basic? The answer is H3O plus ion is equal to 4 into 10 power 5 moles. So the formula for pH is equal to minus log 10 hydronium ion, and if you are substituting that value, you will get pH is equal to minus log 4 into 10 power minus 10 power 5. pH is equal to, if you are splitting that one, then you will get minus log 4 to the base 10 minus log 10 power minus 5. The log value of 4 is nothing but 0.6020 minus of minus 5. So minus of minus 5 is converted into plus 5. So you will get minus 0.6020 plus 5. So the answer is 4.398. Here the pH value is less than 7. So the solution is acidic. Next is question number 8. Here also the same problem is given for calculating, and here you are going to calculate the pH value of nitric acid HNO3. Like the same, you are going to do this two also. Then we will pass on the question number 9. Define the solubility product. This is one of the definition. So the solubility product is nothing but the product of the molar concentration of the constituent ions, each raised to the power of its stoichiometric coefficient in a balanced equilibrium equation. That is, example is XM yn in the solid state gives, in the presence of water, you will get m x power n plus aqueous plus n y power m minus aqueous. So the solubility product, K solubility product only it is written as Sp there. So Ksp is equal to x into x n per n plus concentration the whole power m into y m minus the whole power n. Okay. The next one is another one. Define the ionic product of water. Give its value at room temperature. The answer is the product of concentration of H plus and OH minus ion in water at a particular temperature is known as ionic product. That is the definition for ionic product. And they are asking give its value at room temperature. So the ionic product of water at room temperature 25 degrees centigrade is equal to, the formula is Kw is equal to H plus into OH minus ion concentration. If you are writing the square bracket, that is nothing but concentration. Okay. Then Kw is equal to hydronium ion into OH minus, that is not plus, OH minus concentration. Kw is equal to 1 into 10 power minus 7, and OH concentration is also the same. So 1 into 10 power minus 7. If you are multiplying both the things, you will get 1 into 10 power minus 14 mole squared dm minus 6. Okay. So those are 10 questions I gave you, and you have to revise the remaining. I gave you in the form of a PDF, and you have to see the remaining question answer and you are going to revise it. Okay. Now we are going to next we are going to see the question and answer. Question and answer we already saw, and I gave you the question and answer in the form of PDF, and you have to write and you have to revise that one. Okay. Okay, now I gave you 10 questions revision. The remaining questions I gave you in the form of a PDF, and you have to read and write it as a test, and we are giving you the time to do, so you have to do and you have to write it and give it as in the screen for photo. You have to take the photo and you have to send it to our YouTube, sorry, what is that, WhatsApp number. You have to give it to us. Okay, thank you children, do well and write it properly the answers. Okay ma, thank you.